All right, today we are diving deep into FastAPI, which has become one of the hottest web frameworks in the Python world. And instead of just, listing a bunch of features, we're going to go on a little journey. We're going to build a simple inventory API from the ground up just to see what all the fuss is about. Let's get into it. Right on its homepage, FastAPI makes some seriously bold claims. High performance that can compete with Node.js and Go, easy to learn, fast to code. I mean, these are the promises that are getting so many developers excited. So let's see if it actually lives up to the hype. Okay, so we've heard the claims, but what is this thing really? Let's cut through the buzzwords and figure out what problem it's actually designed to solve. At its heart, it's a tool for building APIs. You can think of it as the engine room for a web or mobile app. It's the part that sits on a server, listens for requests, does some thinking, and then sends back the data the app needs, usually in a nice, clean format like JSON. So here's our game plan for this explainer. We're going to start with the basics, a simple hello world. Then we'll figure out how to structure our data, build out the core functions of our API, connect it to a real database, and then we'll wrap it all up with the most important things to remember. All right, let's get our hands dirty. The very first step with any web framework is just getting something, anything really, to run on a server. So how does FastAPI handle this? Well, the setup is incredibly simple. You really only need two packages, FastAPI itself, obviously, and then Unicorn, which is the server that actually runs our code. Once you've installed those, you just create one single Python file. That's it. You're ready to go. And this right here is one of FastAPI's biggest selling points. I mean, just look at this code. You import the library, you create an app, you write a simple function, and you hook it up to a URL. That is literally all it takes to get a live working web server. It's fantastic. The real magic here is that little line that starts with an @ symbol, the decorator. @app.get// is basically you telling FastAPI, hey, whenever a web browser sends a GET request to my main homepage, the /, I want you to run the Python function that's written right underneath this line. It's that direct link that makes everything so simple. Okay, so our server is running, which is great, but it's not very useful yet. An inventory API has to manage products, right? So our next job is to define what a product actually looks like in our code. And this is a really crucial question. I mean, a product isn't just some random text. It has a specific structure. It has an ID, a name, a price, a quantity. How do we enforce that structure so we don't end up with errors and just bad data? So on the left, you've got a standard Python class. It's fine, but it doesn't really do much for us. But look at the right. This is a class that inherits from something called Pydantic's base model. By using Python's modern type hints, like saying ID is an int and name is a string, Pydantic suddenly understands the entire shape of our data. You should really think of Pydantic as FastAPI's secret superpower. It automatically validates all incoming data for you. So if someone tries to create a product and they give the price as a word instead of a number, FastAPI and Pydantic will just reject it immediately and send back a helpful error message. You get all of this protection for free just by defining that model. Awesome. So now that we can define what a product is, let's build the actual API that lets us manage our inventory. We need to be able to create products, read them, update them, and of course, delete them. And this brings us to a standard acronym you'll see all over the place, CRUD. It stands for the 4 basic things you need to be able to do with any piece of data. And our inventory API is no different. And here's the really cool part. CRUD maps directly to how the web works and how FastAPI's decorators work. To read data, you use an HTTP GET request and the @app.get decorator. To create a new product, you use a POST request with @app.post. It's this super clear one-to-one relationship that makes writing the API feel so natural. So we write a little Python function for each of these operations, we stick the right decorator on top, and boom, we have a fully working CRUD API. But this is where FastAPI pulls a rabbit out of its hat. Based on everything we've already written, our URL paths and our Pydantic models, it generates something truly amazing. This. You get this beautiful interactive documentation page completely for free. It lists all of your API endpoints, it shows the exact data models they need, and it even lets you test your API right there in the browser. This isn't just a nice little feature, it is a massive time saver. It's a game changer for development. Our API is looking great, but we've got a pretty big problem. Every single time we restart our server, all of our products just vanish. That's because the data is just living in a temporary list in the computer's memory. Let's go ahead and fix that. Exactly. For any real-world application, you need what's called persistent storage. The data has to live in a proper database so that it's safe, even if the server restarts. But how do we get our Python code to talk to a database? Well, we use something called an ORM, or an Object Relational Mapper. A tool like SQL Alchemy is basically a brilliant translator. It lets us keep working with our nice Python product objects, and it handles all the messy, complicated stuff of writing the actual SQL code to talk to the database tables. And this right here brings the whole picture together. A request from a user hits our FastAPI endpoint. Our code uses the Alchemy ORM to play with our Python models. And then the ORM translates all of that into SQL and talks to the database. We never have to write a single line of raw SQL if we don't want to. All right, we've built our entire conceptual API. Let's just quickly recap the key benefits that we've seen along the way. So, to boil it all down, it's just incredibly fast to get started with very little code. Pydantic gives you that super powerful automatic data validation. You get free interactive documentation that saves hours and hours of work. And it's built from the ground up to plug right into standard database tools like SQL Alchemy. And all of this leaves us with one final thought. Older frameworks like Django and Flask are still incredibly powerful, and they're not going anywhere. But FastAPI's combination of modern Python, sheer speed, and just an amazing developer experience is making a very, very strong case for being the new default choice. What do you think? Thanks for watching.